This lesson is 4.4, medians and altitudes. We're going to learn what a median is and what it's called where they intersect. And we're going to learn what an altitude is and what the point is called where altitudes intersect. So first, a median of a triangle is a segment that has as its endpoints a vertex of the triangle and the midpoint of the opposite side. These are its two endpoints. So a median has to leave from a vertex and go to the opposite side and cut that opposite side in half. Where medians cross is called a centroid. The centroid of a triangle is the point of concurrency of the medians of the triangle. So if you look down here, this line is considered a median because it leaves from angle B and it cuts the opposite side in half, 4 and 4. This line is called a median because it leaves from angle A and it looks to cut the opposite side in half. And then our third one leaves from angle C and cuts the opposite side in half. So this point where they all intersect is called the centroid. One unique thing about a centroid is the medians of a triangle are concurrent at a point, which is the centroid, that is 2/3 the distance from each vertex to the midpoint of the opposite side. So if I explain that a little differently, if you look at this median right here, doesn't it look like DC is about 2/3 of the way to J? So a median cuts a median, or centroid cuts a median so that there's a piece that's 2/3 of the whole piece and then a piece that's 1/3 of the entire median. So if I wanted to, I could split it like this. So we've got 1/3, here's another third, and then a third. If we apply that to a problem like this, if XA equals 8, what is the length of XB? So I know that XA is going to be 2/3 of the entire line. So if XB is the entire line, I want 2/3 of that. That's going to give me XA. Well, they tell me what XA is. So I'm going to put 8 there. Now I can solve for XB. So 8 is 2/3 of XB. I'm going to multiply both sides by 3. The 3's go away, and I'm left with 2 times whatever XB is equals 24. Then I can divide by 2, and I figure out that the length of XB is 12. For the second one, I'm going to show you a different way to do it. So if ZA equals 9, what is the length of ZC? I'm going to erase my inking and start over. ZA is 9. I know that this piece is longer than AC, so it's the 2/3 one instead of the 1/3 piece. If it's 9, then I know if I cut it in half, this is 4.5, that's 4.5. And then I have my third would also be 4.5. So if I add all of those up, 4.5 times 3, or plus 4.5 plus another 4.5, I'm going to get 13.5. So the length of ZC is 13.5. Second part of this lesson, we're going to learn what an altitude is. So an altitude of a triangle is the perpendicular segment from a vertex to the line containing the side opposite that vertex. So unlike a median, actually similar to a median, they both start at a vertex. But unlike a median, when you drop the line down, it's not going to cut the other side in half necessarily, but it is going to be perpendicular to the base. Now when you learned how to calculate the area of a triangle, you probably heard the word altitude. Whenever you're talking about height of a triangle, we call that the altitude. So sometimes, if you look in the second example, the altitude can be on the outside of a triangle because you have to leave from a vertex and then drop straight down perpendicularly to the base. So if I had an even more extreme example, here is a triangle. And if I want to draw on an altitude, it's going to leave from the vertex, drop straight down to the base. Now I know the base isn't over here, but we could do a dashed line to extend. This would be your altitude right here. Where the altitudes cross is called the orthocenter. The orthocenter of a triangle is the point of concurrency of the lines containing the altitudes of the triangle. So in this example right here, point D is your orthocenter. So let's practice identifying medians versus altitudes. So part A for this triangle shown right here is PR, right here, a median, an altitude, or neither? Well, I know right away it's not a median because it does not split the opposite side in half. I do see a right angle, so I'm going to look at it and see if it is an altitude. If it is, it leaves from a vertex, and it's perpendicular to the triangle's base. So it looks like, yes, this is an altitude. Next one is QT. Let me change colors. A median, an altitude, or neither. So here's QT. I know right away that it's not an altitude because I don't see a right angle symbol. So it's not an altitude. If it's a median, it leaves from a vertex and it cuts the opposite side in half. And I see that is the case, so I know it's a median. And then last, for the bottom one, for triangle ABC, is AD, a median, altitude, or neither. So let's use red again. AD. Again, I see that there is no right angle symbol, so it's not an altitude. If it's a median, it leaves from a vertex and it cuts the opposite side in half, and I see that it does cut CB in half. So it would be a median. This is probably the trickiest part of this lesson, finding the orthocenter. And if you can remember, a centroid is the point where all the medians cross. The orthocenter is the point where all the altitudes cross. So we have this triangle ABC, and we have to find the coordinates of the orthocenter. In order for me to do that, I need to draw in all of the altitudes. So I'm going to start with the easiest one. If I start at vertex B, I know I can go straight down, and I automatically know that that is perpendicular to the base because it aligns with the grid. So there's my first altitude. Now I need to choose, do I want to go from angle A or from angle C for my next altitude? I'll start with A. If A is approaching BC, I notice that BC's slope is a -1. So if I need to draw a perpendicular line, if you remember, down 1, run 1 would be BC's slope. To find a perpendicular line, we need to use the reciprocal and then change the sign. So it's going to be a positive 1/1. So if I go from A, I'm going to go up 1, over 1, up 1, over 1, and continue until I hit the opposite side. Now, I could go ahead and use the same strategy, leaving from angle C, but if I already see where these two altitudes cross, I know the third one is going to cross there as well, so I don't even need to bother with that. So it looks like they cross at 2, 4. And then we'll try one more time, so why don't you pause this video, try to find the orthocenter, and then when you press play again, you'll see the solution. So if you constructed the altitudes correctly, you'll see that the orthocenter is at 1, 3.